What do you mean by that virtual? So the method is very simple. So what we'll do is like, I will take two laser guns. Okay, that one. So they will emit a light. The emitted light, instead of converging at this particular point, undergo refraction and will converge here. This idea. So the focus, the sharp focus, instead of here, you'll get it here. So there's a laser gun. Hope everyone is getting some idea what do you mean by virtual here. The virtual means only take two laser guns, let it get focused at a point. Instead of converging here these two rays, they converge at this particular point. So therefore, this should be real. This is a virtual. If the refracted rays converge at a point, real. If the incident rays appears to converge at a point, that should be a virtual object. So how we define real or virtual things? With respect to refracted rays, we should have the idea. So here we'll just have a some brief discussion. Will make it so that the coming topic this is going to help us a lot. If incident rays diverge from a point, the point of divergence is a real object. Then if the incident rays converge, appear to converge, if the incident rays appear to converge at a point, the point of convergence is a virtual object. Now, if refracted rays diverge from a point, the point of divergence is a virtual image. Next here, if refracted rays converge at a point, the point of convergence is a real object, sorry, a real image. These are the, for refracted rays, these are the rules, what we should know. Okay, there's only theory, this is all about the theory. We must work out numericals again. They're just only information. Suppose if there are multiple layers of liquid are there, then what conditions will come? Multiple layers of liquid. What do you mean by multiple layers of liquid? Here, if I get like this, there's a one layer. Okay, now if the layers are there, H1, H2, H3, I kept a coin here at the bottom. Okay, fine. At the bottom of this container, a coin is kept. This is mu3, mu2, mu1. Let me view normally. They do it will appear. Multiple layers are there. Earlier there was only one layer, no? Now there are multiple layers are there. Then what conditions will come? Then the apparent depth from here is what will measure. The apparent depth should be equal to the apparent depth offered by the individual layers, that one. So what is the, due to this layer, how much h1 by mu1, due to this layer will be h2 by mu2, h3 by mu3, h1 by mu1, h2 by mu2, h3 by mu3. Add up apparent depth due to individual layers. Sir, like if the object is not at the bottom, apparent, what is HA? Apparent depth of coin. The particular coin may appear anywhere here. The coin may appear here, may appear here, may appear, anything it can be. If the coin is somewhere here, what you do? Then this will not get added up. Small thinking. Next situation. If the coin, I'll keep it somewhere here. So where do that coin will appear for us? So this will be H2 by 2. So mu1, mu2, mu3. I'll weave it normally. Okay, I'll weave it normally, that one. In that case, so the apparent depth will be h1 by mu1 plus h2 by 2 mu2. The layer, this layer will not come into picture because the rays emitted by it will undergo refraction here and here. Will not undergo any refraction here. So therefore, the apparent depth due to layer 3 will not come into picture. What is the basic idea is that the rays emitted by it will come here. Okay, fine. It will be. And finally, yeah, the rays emitted by it will undergo refraction. So no question of the mu3 will not come into picture here. So please try to understand the concept here, sir. Why you are writing formula? Not like why I'm writing the formula. The rays here will undergo refraction. The rays will undergo refraction. The rays will undergo refraction. So therefore, the apparent depth of three layers will come. Here the ray will undergo refraction at between mu2, mu1 and mu1 and air. So therefore, the apparent depth of this liquid and this liquid also will come into picture. This mu3 will not come into the final answer. And you should calculate this H2. What is H2? This is what is the depth? If the multiple layers also, no problem. So we can use this particular formula. Okay, if there are n liquids are there, we can take help of this particular formula. Now next condition. If the refractive index of the liquid varies